So continuing on the conversation of algebra of functions, we're going to move on to another example, and I've chosen the wording straight from the textbook. So what they're going to do is they're going to say, for these pair of functions, find each of the following. So we're going to look at the function f of x is equal to 1 over x, and g of x is equal to x plus 2, and we're going to A, find the domain, and then B, do all of this algebra of functions. So I chose this one specifically because it has an x in a denominator, and just to look at how that's going to affect our different domains. So what we're going to do is we're going to do the first part of A, so we're going to find the domain of f of x and g of x, and then we'll jump between B and A and C and A and so on. So we find the domains as we go. So first off, we'll start off with the domain of f of x, and we'll start off with the domain of g of x. So f of x is 1 over x. What would be the domain? Well, things that restrict the domain are things like x's in denominators and x's in radical signs, and by x, any variable can stand. So since this has an x in a denominator, that would mean that the x cannot equal 0, because you cannot divide by 0. And interval notation is great. I prefer interval notation. Our textbook seems really stuck on I don't know what I just said there. I love set notation, which is this, but our textbook is very stuck on interval notation, which is, instead of telling you that x cannot be 0, it says what x can be. So it's everything from negative infinity to 0 and from 0 to infinity. When we look at the g of x function, the g of x function is x plus 2. There's no x's in denominators, there's no x's under radical signs, therefore in set notation x can be everything, and in interval notation that means it can be everything from negative infinity to infinity. Now we could technically go through and do the domain of f plus g, f minus g, and so on, but I find it easier to do them as you to figure out the domains as you write them, because then you can physically see the different domains. So let's go on to B. The B, they want you to do f plus g of f, or it's been a long day. They want you to do f plus g of x. Now what they're asking you to do here is to take the f of x function and add the g of x function. So I'm going to substitute in for f of x, 1 over x, and I'm going to substitute in for g of x, x plus 2. Now I always substitute in brackets in case there's anything I need to do. This one, because it's adding, I can just remove the brackets and say that it's 1 over x plus 2. Now technically you could go further, you could create a common denominator of x and write it as a single term, but luckily the textbook is happy with this, so we're just going to leave it like this. Now let's talk about the domain. The domain of my original f of x function is that x cannot equal 0, so that's going to still hold. The domain of g of x is everything. That's going to still hold. And then because it was adding, there's actually no new restrictions on the domain. So because the f of x function was there, my domain is x cannot equal 0. What can it be? Well, it can be negative infinity to 0, and then 0 to infinity. I'm just going to write that. I'm conscious of how much space I have on this page. I'm just going to put the domain here. So the domain is that x cannot equal 0, but it can be everything from negative infinity to 0 and 0 to infinity. All right, let's look at C. In C, they want us to do f minus g of x. Again, you could write the domain right now. Because there's an f of x function and a g of x function, my domain is going to be x cannot equal 0, or negative infinity to 0, and 0 to infinity, and nothing new. Okay, as long as you don't have anything dividing, so you don't introduce any new denominators or any new radicals, the domain's actually not going to change. So it's why they do ask it in A. They're like, go ahead, do all of your domains, but it does get tricky when you get to division, so we're just going to take them piece by piece. Then what we're going to do is we're going to realize that this means that they want you to do the f of x function minus the g of x function. So my f of x is 1 over x, my g of x is x plus 2, and now that minus sign is going to change the signs of everything over here. So this is just a 1 over x, and then we're going to minus x minus 2. And again, we're just going to leave it there. Then we double check our domain. Oh yeah, look, hey, there's still an x in a denominator. X cannot equal 0. Then we'll move on to D. In D, they want you to do fg of x. And again, this means that they want you to take f of x and multiply g of x. f of x domain still holds. G of x domain still holds. No division. This is going to be the overall domain in the end. So I can predict that already at the beginning, but we will double check it at the end. To multiply, we have 1 over x for f of x. We have x plus 2 for g of x, and then we're going to multiply. Now to multiply this, there's a couple ways of giving the answer. The way that the textbook likes to write it is to multiply this through and then have an answer with two terms. So for example, 1 over x times x is like multiplying by x over 1. So 1 times x is x times 1 is x, plus, again, 1 times 2 is 2, x times 1 is x, and then this would simplify to 1 plus 2 over x. If you answered as x plus 2 all over x, that would be a perfectly acceptable answer as well. You know, math is tricky that way. There's lots of ways of displaying an answer, but the textbook, for whatever reason, has preferred this time to give this as an answer. And then we double check the domain. Oh, hey, look, the domain of this is x cannot equal 0, just like the domain of f of x was x cannot equal 0. And if this was different, and there wasn't an x in the denominator, this would still hold, right? So the domains do not change. Okay, the next thing we're going to do is E, which is f of g, or sorry, f of f times f of x, and I just realized I did the spacing thing again. I like to give myself room, so I'm going to put E over here. One sec. There we go. I just know I've filmed this video before and I ran out of room doing f and g, which I don't want to do. So E. E is that we're going to do f times f of x. And if it's helpful for you, again, that's f of x multiplying by the function f of x. So I'm going to rewrite f of x as 1 over x. I'm going to replace f of x as 1 over x, and then I'm going to multiply. 1 times 1 is 1, x times x is x squared, and the domain would simply be x cannot equal 0. X can be everything from negative infinity to 0 and 0 to infinity. That was the original domain. It's actually the new functions domain. Everything works. The last thing we're going to do are division. So the first thing we're going to do is f divided by g of x, and then we're going to do g divided by f of x. So in f, I've already forgotten. F is f divided by g of x. So what that means we're going to do is we're going to take the f of x function and we're going to divide it by the g of x function. Now, when we talk about domains, our original domains would hold. F of x would tell us that x cannot equal 0. G of x didn't have any restrictions, but now because this is division, there's a new restriction. So for these, for the domains, you'd have the f of x domain, right, which told us that x cannot equal 0. We'll have the g of x domain, which was that x can be everything. But now, because g of x is in the denominator, g of x also cannot equal 0 because g of x as a function is now in the denominator. So now when we put our functions together, f of x is 1 over x, and g of x is x plus 2, looking at the two functions, my domain would be x cannot equal 0, but now that we've put x plus 2 in a denominator, we would also have to say that x plus 2 cannot equal 0, so x cannot equal negative 2. So we've got this new restriction. So for this one, my overall restriction would be, in set notation, x cannot equal negative 2 or 0, and in interval notation, it would be everything from negative infinity to negative 2, everything from negative 2 to 0, and then everything from 0 to infinity. Okay, so it's a little bit more complicated, only that if you put a function in the denominator, even if it doesn't have a domain, it now becomes a domain because it's in a denominator, if that sentence made sense. Now, what are we going to do with this? Well, this is a complex fraction, which is the whole reason I put this example in here, because people get stuck on here. Up until now, there wasn't much new. But how do I get out of this complex fraction? Well, if you remember from the essential skills, there's two ways of doing it. Way number one is to write this as a division. This is 1 over x being divided by x plus 2. How do you divide fractions? Well, you flip and multiply the second fraction. So this would be 1 over x plus 2. And then you multiply across. So 1 times 1 is 1, and then x times x plus 2. And this would actually be a fine answer, and then it's easier to see these two restrictions. But you could also answer this as 1 over x squared plus 2x. It doesn't matter to me. If it's multiple choice, you should be able to recognize both. So this is my final answer for f divided by g of x. The last question we're going to do is g. And I actually left myself enough room. And in g, we're going to do g divided by f of x, which means we're going to take the g of x function and divide it by the f of x function. So again, when we're talking about domains, we would say the domain of f of x was that x couldn't equal 0. The domain of g of x was that x could be everything. But now we're putting the f of x function in the denominator, and it cannot equal 0. Well, that's fine, because we already have this restriction of x cannot equal 0, which it can't be. So that's actually not going to change my domain at all, and my overall domain will be x cannot equal 0, or negative infinity to 0, 0 to infinity. It's getting a little repetitive, hey? And then let's look what the functions turn out as. So we've got x plus 2 divided by 1 over x. And again, I would just write this as a division. So x plus 2 divided by 1 over x. And then I would flip and multiply to have x plus 2 times, now I'll put this in brackets, x over 1. And then I'm multiplying the x through. So I end up with x times x plus 2, or simplified, x squared plus 2x. Awesome. Now here's the tricky thing, is that this is my simplified function. This is g divided by f of x. And if I looked at this, I would say, well, x can be anything it wants. Why am I saying that the domain to this is x cannot equal 0? Well, it's because when you look at a function, even though this is the simplified version, it's the simplified version of this. And this has that restriction, x cannot equal 0. So since my original algebra of functions had a restriction, even though when I simplified it, that restriction no longer is visible, it still exists, because this is a simplified version of this that has a domain of x cannot equal 0. Talk about a confusing sentence, but it's true. The other thing I wanted to say is I did mention there was 2 options. So if anybody's doing this question and I said, hey, you know what, you're going to simplify this complex fraction. If you don't like doing the flip and multiply thing, or maybe it doesn't work out for a certain scenario, don't forget you can also multiply by 1, meaning you multiply by the lowest common denominator in both the numerator and the denominator. So that's just x, and then you multiply it through. So in my numerator, I have x over x, which is just 1, and then in my denominator, I have x plus 2. So if you wanted to use this as your method for simplifying the fraction, you're more than welcome to. It means absolutely the same thing, except I just wrote that really funny. I lost my 2. There we go. And then same thing for this guy. If you have x plus 2 divided by 1 over x, again, you can multiply by 1, including the common denominators. So then I would multiply through, and I would end up with x times x plus 2. Did it again. X plus 2 divided by x times 1 over x is 1. So I would get the same answer. So it's just how you like to clear complex fractions, whether you like to do it as flip and multiply, or whether you want to do it by multiplying by 1. All right, good luck.